Ever pour your heart out to one of those AI chatbots? Dreaming of the day you'd have your own C-3PO buzzing around, making you a martini?
Yeah, I think we all have.
Totally. And today's deep dive is all about that. Why, despite all this AI craziness, those slick robot butlers are still stuck in sci-fi.
Right. Like, where's our robot uprising?
Exactly. So we're taking Victoria Turk's recent article in The Observer. It's called, get this, it's the robot we were all expecting, like C-3PO. Why aren't humanoids in our homes yet?
Catchy title.
Isn't it? Well, we'll link in the show notes, of course.
Yeah.
But yeah, we're going to dive deep into this whole robot mystery.
Love it.
Because, I mean, the title says it all, right?
Yeah.
AI is out here conquering complex games, writing poetry, even composing symphonies.
Don't forget those deepfake videos, too. Wild stuff.
But me, my biggest robot flex at home is still that little guy vacuuming under the couch.
And let me guess, it still gets stuck sometimes.
Always.
Yeah.
So what's the deal? Why is it so much harder to build a robot that can, like, I don't know, make us a decent sandwich?
Or fold a fitted sheet.
Yes. Than one that can write a Shakespearean sonnet.
Right, right. Well, it's easy to get caught up in the idea that AI is all about pure brain power, right? Like it's all about raw processing power and fancy algorithms.
Yeah, makes sense.
But what we often overlook is the sheer complexity of the body. Like our bodies as humans are incredibly intricate and adaptable. Turns out building a robot that can move and interact with the world the way we do, that's a whole other ballgame. It's not just about the software.
So it's not enough to just have a super smart AI.
No.
You need a body that can actually, like, execute those smarts in a meaningful way.
Think about it this way. Coding a complex AI is like writing a symphony.
Okay.
It requires brilliance, creativity, don't get me wrong. But it's ultimately about manipulating symbols in a digital space. Building a humanoid robot, on the other hand.
Okay.
That's like building the concert hall, the orchestra, and crafting each individual instrument all at the same time.
Wow. Okay, that analogy really puts it into perspective. So it's not just about having the right software. It's about the physical act of bringing that intelligence into the real world.
Precisely.
Okay, now that makes a lot more sense.
And here's a mind-blowing fact from the article. Are you ready for this?
Get me.
The basic mechanics of some robot bodies haven't changed drastically since the 1950s. And yet here we are still grappling with the same fundamental challenges of getting robots to move smoothly and interact with their environment.
It really makes you appreciate just how complex our own bodies are, huh? But, okay, so if building a robot hand that's exactly like ours is so hard, are there other ways to go about it? Like, do robots even need 5 fingers to be useful?
That's the million-dollar question. And the article actually digs into that a bit. There's a company, Shadow Robot. They're doing some really cool stuff. They've created this dexterous hand.
I read about that. It can, like, pick up an egg without crushing it, right?
Yep. It's the same size as a human hand and capable of some seriously delicate manipulations.
Okay, so with hands like that, it feels like those C-3PO dreams are within reach, no?
Well, not so fast. Here's the catch. While the hand itself is amazingly lifelike, it needs a huge robotic arm to function. It's a good reminder that we haven't quite figured out how to miniaturize that level of dexterity.
So I can have a robot that can make my morning omelet,
Sure.
but it'll need an arm the size of a small car to do it.
Yeah.
Not exactly what I had in mind.
Yeah, not the most practical kitchen appliance. But hey, Shadow Robot, they're not giving up. They've also got this other thing called DXE.
DXE, what's that?
It's a completely different approach to robot hands. Instead of trying to perfectly copy the human hand, they went with a simpler design. Just 3 fingers.
3, that's all.
That's all. But get this, it's incredibly strong. The article even said it can withstand a blow from a mallet.
Okay, so maybe not as elegant, but I can get behind a robot that can handle the tough stuff.
Exactly. We're talking heavy lifting, dangerous tasks, all without breaking a sweat. Or a finger, for that matter. But building the body is just half the challenge, you see. We also need the brain power.
The AI that actually makes the robot tick.
Exactly. We can have the most advanced hand in the world, but without the smarts to control them, it's all just for show.
Makes sense. A robot that can move its fingers but can't figure out how to hold a glass of water isn't very helpful.
Exactly. And this is where things get really cool. The article talks about how DeepMind are using this thing called reinforcement learning to teach robot hands like DXE how to actually interact with the world.
Reinforcement learning. I feel like I've heard of that, but remind me.
It's like teaching a kid how to ride a bike, except, it's a robot hand, and instead of scraped knees, there's just lines of code.
Right, right. So you're saying they basically Let these robots loose in a virtual playground and let them figure things out on their own.
Pretty much. Instead of programming every single movement, they create a simulated environment. The robot can experiment, make mistakes, learn from them, just like humans do.
That's wild. So you're telling me these robots are basically learning through trial and error?
Exactly. And it's proving to be way more effective than old school programming methods, especially when it comes to those super delicate, nuanced movements.
Like picking up a strawberry without crushing it.
Exactly. Pretty cool, huh?
It really makes your brain do a backflip, doesn't it? Training robots in a virtual world so they can function in the real one. Big thanks to Victoria Turk for getting this conversation started with her thought-provoking article.
She really nailed it with this one.
And to all of you listening, thanks for joining us for another deep dive. Until next time, keep exploring, keep asking questions, and remember, the future is closer than it appears.